Have you ever imagined stepping into a machine, pressing a button, and being transported to the year 3025, or perhaps to ancient Egypt? Time travel is one of humanity's oldest and most exciting fantasies. From H.G. Wells' classic novel The Time Machine to blockbuster films like Interstellar and Avengers Endgame, the idea of moving through time has fascinated us for centuries. But here's the big question: is time travel scientifically possible? Or is it just a dream dressed in scientific jargon? Let's take a deep dive into the science behind it. Hourglass knot on time, a flexible dimension? According to Einstein's theory of general relativity, time is not a fixed, unchanging flow like a ticking clock. Instead, it is part of a four-dimensional fabric known as spacetime. And this fabric can be bent, stretched, and warped by gravity and speed. In fact, we already know time travel to the future is possible. It's called time dilation. When you travel at speeds close to the speed of light, or when you're near a massive gravitational object like a black hole, time slows down for you compared to someone far away. This has been proven through experiments with atomic clocks on high-speed jets and satellites. So, in a way, astronauts aboard the ISS are already experiencing a tiny bit of time travel. Repeat button: can we travel to the past? Now here's where it gets mind-bending. Traveling backwards in time is much more complicated and controversial. Some scientists, like Kurt Gödel, propose the idea of closed time-like curves. These are paths through spacetime that loop back to the past. Sounds amazing, right? The problem is, creating or finding such a loop would require exotic conditions, such as rotating universes or negative energy, which we haven't observed. Another theory suggests using wormholes, hypothetical tunnels in spacetime. If one end of a wormhole were accelerated to near light speed and then returned, time at each end would flow differently. In theory, stepping through could send you to the past or future. But there's a catch: wormholes are incredibly unstable. Keeping one open long enough for travel would require exotic matter with negative energy, something that exists only in theory. Counterclockwise arrows, button paradoxes, and alternate timelines. Even if we could go back in time, what happens then? The most famous dilemma is the grandfather paradox. If you travel back and stop your grandfather from meeting your grandmother, how could you have been born to time travel at all? To solve this, some scientists believe in the idea of multiverses or branching timelines. Any change you make in the past creates a new, alternate timeline, leaving your original timeline untouched. Others suggest that the universe may self-correct, preventing paradoxes from happening at all. No matter what you try, events will always somehow lead to the same outcome. DNA, quantum physics, and the future. Quantum mechanics, the science of the very small, opens even more mind-blowing possibilities. Some interpretations, like the many worlds theory, propose that every possible outcome already exists in a separate universe. So if you time traveled, you wouldn't change your past, you'd just move to a different version of reality. Scientists are also exploring quantum entanglement and retrocausality, ideas that hint at time and cause-effect not working the way we think. Rocket so. Will we ever time travel? At this point, time travel remains a theoretical concept. While we have evidence of time moving at different rates depending on gravity and speed, true time machines, especially for backward travel, are still far from our reach. But as science advances, especially in quantum physics and space exploration, the impossible often becomes possible. Maybe one day, time travel will move from science fiction to science fact. Until then, we'll just have to explore the future, one second at a time.